This is a video recording for a physics GCSE test for the Edexcel IGCSE 921 specification. It's paper 1P, therefore it's the physics paper 1 and the physics section of the double award science. So for this one we're only looking at units 4 and 5, which are energy and solids, liquids and gases. My students have just finished unit 5 and I'm making them revise 2 as a preparation for the January mock where they'll have to prepare for all the units that we covered so far. Okay, so these are the only formulae that you'll be given this year. Last year they gave a few extra formulae because continuation with the COVID policy. So these are the only formulae that you'll be getting in this exam. And for for units 4 and 5, you probably only need these ones. So they give you Boyle's law, pressure law, and this one will be useful because it's linked with change of energy. So this one is how MGH, potential energy, can be converted into kinetic energy. And if you actually can simplify it, that's how this equation is derived mathematically. So these are the equations that you'll get for this paper. The first question is on forces. It's about floating, so it's about density. It says a ship floats because the force is acting on it. The upward force is called upthrust, which is already labeled for you. And that's shown in the diagram. They want you to draw another arrow on the diagram to show the other vertical force acting on the ship. So of course that's the weight, and the weight will act from the center of the boat. So you could draw that as a center, and the arrow down, because the forces are balanced, must look like it's equal in length to the upthrust up. So as long as it to the eye it's equal, in the exam you should draw it with a pencil and a ruler. Okay, so the weight downwards is balanced by the upthrust upwards. Because forces are vector quantities, direction matters. Then they want you to remember what a vector quantity is. Well, a vector quantity has two things. It's a quantity that has size or magnitude, is the more scientific way of saying size, magnitude, and has direction. So anything that can be represented with an arrow is basically a vector quantity, like a force, a velocity, or an acceleration, or anything that has velocity in it, such as momentum. So they want you to give another example of a vector quantity. So it could be displacement, yeah, it could be also velocity, which it's the vector quantity of speed. It can be acceleration. Any of these will get you the mark, but they will take your first word that you write down. And also momentum, because momentum is mass times velocity. Those are the ones that I would recommend. So that's how you get the 5 marks for the first page. Then going over the page, it says the upthrust acting on the ship is proportional to the pressure difference. So they want you to be able to link it to the pressure difference equation. The pressure acting on the top of the ship, acting on the ship at the surface of the sea, is 100 kilopascals, which is atmospheric pressure. And that's 100 kilopascals, 100,000 pascals. They want you to state the formula linking pressure difference, height, density, and gravitational strength. Well, so if you know that's the P, that's H, that's density, which is the Greek letter rho, and this is G. And if you put them in words is the best, but I'm going to just, for the sake of the video, I'm going to put pressure difference is equal to H rho G. So pressure difference you should write equals height times density times gravitational field strength. So you should write this out in full to get the marks. So definitions in physics are normally given by the word equations, just expanding the focus, the magnification. So then they want you to use this equation, and they say the bottom of the ship is 15.8 below the surface of the sea. So at the top of the sea, at the top surface of the sea, there's the atmospheric pressure, which is 100,000 pascals already from the atmosphere, and the bottom of the ship is 15.8 meters below the surface of the sea. So that's the H in this equation. Show that this pressure difference, the 15.8 meters of water, seawater, is approximately equivalent to 260 pascals. Well, I've told my students every 10 meters of water is about 100. So this is about 16 meters of water. They've given you density of seawater as being slightly more than normal water, which is 1,000 kilograms per meter cubed. So they're giving you 2 in meters. So you're going to basically use that equation, P equals H rho G. Put the numbers in. So the pressure difference due to the 15.8 meters is 15.8 times the density, which is 1,030. Seawater is denser than normal water because of the salt and all the minerals in it. And G, yes, in this equation is always 10 newtons per kilogram, which is given to you on your data sheet. So you always multiply by 10, put the numbers in, and you will get 1 mark for putting the numbers in, 1 mark for the answer, 1 mark for putting the numbers in correctly, and 1 mark for the answer. So if we look at the answer on there, it comes out to 15.8 times 1,030 times 10, which gives you 162,740. So it's 162,740, which is approximately 160,000. 160 kilopascals, 160,000 kilopascals, because they want you to only do two significant figures. But then you've got, they want you to know the pressure acting on the bottom of the ship. So it's 160 extra, yes, that's extra pressure due to the water. That's the pressure difference. Plus 100,000 kilopascals from the atmospheric pressure above the water. So when you add that together, the total pressure is 260 kilopascals. That should be pascals. So I hope that makes sense. So 100 is due to the atmosphere, 160 is due to the 15.8 meters of water, which causes an extra 160. So they want you to realize it's a pressure difference. It then says, explain why the bottom of the ship is deeper below the surface of the sea when the ship is fully loaded. Well, if the ship is fully loaded, what's going to increase on your force diagram? The weight of the ship will increase. Is higher. But the upthrust will not increase to the same amount, because upthrust is due to how much fluid you've displaced, and so the downward force is greater, so there'll be a greater resultant force downwards, which will push you further into the sea. Okay, so it has to go in deeper. It will have to go in deeper. So if the upthrust will not increase the same amount unless it displaces more water. So it needs to go in deeper for so there is a greater resultant force downwards until the upthrust increases. So that basically, to increase, it needs to go in deeper. Yeah, by sinking in lower. Okay, so here's the way that they're marking it. Idea that the weight of the ship down was greater, larger pressure difference when deeper water, and that larger pressure difference is what's going to give you the extra upthrust upwards. Okay, so weight of the ship is higher, but the upthrust will not increase the same amount until it displaces more water. Therefore, it needs to go deeper. Yeah, so H must increase. And that's from this equation up there. Okay, so when the H increases, the upthrust will increase. H increases, upthrust increases. So you get 1 mark for realizing the weight goes up. The upthrust then reacts to the extra weight, pushes the boat further down. Upthrust increases due to the depth sinking lower, and that's a greater pressure difference. So there's quite a lot to this question. The greater pressure difference creates the upthrust. Okay, so all these points to make sure you're getting all the examiner's marking points. And just this is, if you want to stop the video, there is all of the answers in for question 2 with the marking points. Okay. The next question is question 6 is from the energy topic. So the energy topic is a teacher makes a hot drink and puts it in an insulated cup. Yeah, and the insulated cup is designed to keep the drink hot. So the photograph and the cross-sectional diagram show the cap. So this is what it looks like, and this is a cutout diagram, and you see there's a vacuum, there's a shiny metal surface on the outside and on the inside, and the plastic lid. So this question is about minimizing heat transfer in 3 ways: by conduction, by convection, by radiation. So your answer should cover all 3. And they've given you, so they want 6 marks for this over the page. They've got 6 marks to award for this. So, and they give you a whole paragraph. So you've got to give the 3 points that I made. You have to refer to the method of energy transfer in your answer. So they're talking about methods of heat transfer, and the heat transfer it can be due to conduction if it's in solids, convection if it's in fluids, and radiation can go through empty space. Okay, so how do we reduce and minimize that? So the best way to do that is to look at what they're giving marks for. So the marks they're giving, any 6 from these, they're giving 9 ways of getting the marks. So the idea that energy is trapped inside the well-sealed cup, as the cup slows down or stops the energy transfer to the surroundings, as long as you got that, that's the first part. Then relating to conduction, the vacuum in the between the 2 silvery walls contains no particles, so that reduces or stops conduction. They'll accept either way of putting it, through the sides, the walls of the cup. And then the plastic lid is also a poor conductor, so it's a good insulator. So if you make points about that, this is all relating to conduction. The next part is relating to convection. Air is trapped by the lid, reduces or stops convection. I would put reduces, but it does actually stop a lot of the convection from the surface, because convection happens in fluids by the hot air rising, and the hot liquid will heat the layer of air above it by just conduction, by touching actually, so that's conduction. So by preventing the by having a tight lid, once the air above the drink, so you say it's coffee or whatever, hot coffee, once it gets warm, it can't then leave the cup, and circulation currents, convection currents, is when the hot fluid tries to go up In this case, the air will hit the top and it will just basically fall back down again, but it can't escape through the lid, so it minimizes heat loss through convection. And then relating to radiation, the shiny surface is a poor absorber of infrared, so the radiation from the heat of the coffee, anything hot radiates its heat. The radiation is reflected back in by the shiny surface, so you need to say that, allow the idea that surface reflects some of the radiation back in, or they said heat rather than radiation. Really, you should use infrared is the correct name for heat, which you did in the waves topic in year 10. And the outer shiny surface is a poor emitter, so if anything does get through, shiny surfaces do not then emit as much heat or infrared radiation. Okay, so it again minimizes the transfer of heat through radiation by having the shiny surfaces, and energy transfer by radiation is therefore reduced by having the shiny surfaces. Sorry, the focus seems to be a little bit out, so I'm going to stop the video there, having done question 1, 2 and 6, is it 1 and 6 we've done. So I'm going to go and do a follow-up video for the other questions. Hopefully, if I restart the machine, the focus will be a bit better. Okay, so thanks for watching this. Will help you prepare. So basically, every time I do a couple of exam questions on a particular topic, I will upload them to the YouTube channel. So thanks for watching. If you found it useful, please show your support by giving us a like, and share it with anyone who's doing the same paper as you, and subscribe if you want to know when the next video is going to be uploaded. Okay, bye for now. See you in the next video.